everybody? So we are looking at Master's theorem, right? Master's theorem for decrease and conquer case, divide and conquer case. Again in divide and conquer, we are discussing theorem 1 and theorem 2. Hope you have remember the formulas. I'm just writing on the high level. This is for decrease and conquer case. Just trying to remind you, okay? Decrease and conquer case. If the relation is like this, T of n is equal to A into T of n minus B. This is minus, that's why it is decrease and conquer. Okay? Plus f of n format. And this function, if this function is in the format of n power d, which means it is some constant into n power. So if the f of n function is like polynomial, then you can apply this theorem. Okay? Decrease and conquer case, Master's theorem. But if it is not in n power d format, which means it is not polynomial, then you have only substitution method. Okay. So then the answer is T of n is equal to O of n power d if a is less than 1. A means this value which is present in front of T of. Okay. If it is less than 1, this is the answer. It is n power d plus 1 if a is equal to 1 and it is equal to n power d into a power n by b. If a is greater than 1, this is decrease and conquer case. So the answer depends on a value. Now divide and conquer case. This is divide and conquer. So if T of n is a into T power n by b, this is by, that's why it is divide and conquer. Okay, if it is minus, it is decrease and conquer. Plus f of n. And this f of n is in terms of n power d. Means it is in polynomial format. Okay. Then you can apply this theorem 1. This is theorem 1. Okay. Then T of n is equal to big O of n power d if a is less than b power d. It is equal to n power big O of n power d into log n if a is equal to b power d. It is equal to n power log a to the base b if a is greater than b power d. Okay, this is theorem 1 and you must remember it. If you want to avoid substitution method, you must remember Master's theorem, and in gate you need Master's theorem. We cannot go by substitution, it will take too much time for the expressions that we are getting. Right, theorem 2. When do we apply theorem 2? If f of n is not in terms of n power d, it is not a polynomial, which means it is 2 power n, n by log n, n factorial, n power n. Okay, so in all those cases it is not polynomial, then you go for theorem 2. Okay, and in theorem 2, we have case 1. If f of n is big O of n power log a to the base b minus epsilon for some small epsilon greater than 0, then T of an answer is theta of n power log a to the base b. Case 2. If f of n is theta of n power log a to the base b into log n whole power k. It is theta. If it is like this, okay, then the answer depends on k value. If k is greater than or equal to 0, there is one answer. If k equal to minus 1, there is one answer. If k is less than minus 1, there is one answer. Okay. In the first case, T of n is equal to theta of n power log a to the base b into log n whole power k plus 1. In the second case, T of n is theta of n power log a to the base b into log n. And in the third case, T of n is equal to theta of n power log a to the base b. That is case 2. We will, as I told you, we will solve many questions on this and this. Okay. But as I told you earlier, there are not many GATE questions on theorem 2. In university exams, definitely you may not get, but in GATE also, In all these years, we could see only 2 questions by using theorem 2, but you must remember, no doubt. Case 2, then case 3. If f of n is equal to big omega of n power log e to the base b plus epsilon for some small epsilon greater than 0 and a into f of n by b is less than, okay, some constant into f of n. Okay, so if this is also true, if the first condition is true, 99.9% the second condition is also true. Even if you don't check, that's okay, but we will anyway check because it is there in the theorem. Okay, then T of n is equal to theta of f of n. Theta of f of n. So this is theorem 2. If you remember these formulas, now we will solve many questions. They are for practice, okay? Anyway, we will solve gate questions. Then you will understand what type of questions will be there. But till then, we will solve practice questions. I will write different recurrence relations. Last week, we learned how to write recurrence relations, right? Everything. Recurrence relation. Why should we write recurrence relation? First of all, if we have to find the time complexity of a recursive algorithm. If it is a recursive algorithm, first we need to write the recurrence relation, which looks like this or like this. Okay, and then you solve it. Solve it by using substitution method, but that takes time. That's why we are learning master's theorem, so that we can straight away get the time complexity. Okay, so our intention was to find the time complexity of recursive algorithms. Non-recursive for loops, we have already written so many questions on that, and then we find the time complexities. Right now we are looking into recursive algorithms. So last week we learned how to write the recurrence relation. Now this week we are solving it by using master's theorem. Okay, substitution method also last week we have seen. I'll raise them and then I'll write different recurrence relations. You need to tell me the answers by applying these theorems. Yeah, I'm writing different recurrence relations. T of n is equal to T of n minus 1 plus 1. First one, T of n is equal to T of n minus 1 plus n. T of n is equal to 3 into T of n minus 1 plus 1. T of n is equal to T of n minus 1 plus C into n square. T of n is equal to 2 times T of n minus 1 plus 1. T of n is equal to 2 times T of n minus 1 plus n. I'm writing all of them, okay? We'll solve one by one. T of n is equal to 4 times T of n by 2 plus C into n square. C is constant. Even if C is not there, still that's fine. T of n is equal to 8 into T of n by 2 plus n square. See, all these questions I am writing it from Algorithms Coreman book. Okay, I am writing each and every question which is given in the exercise from Coreman book. Okay, which is like a Bible for algorithms. T of n is equal to T of n by 2 plus root n. 4 into T of n by 2 plus n. T of n is equal to T into n by 3 plus n. 2 into T of n by 2 plus c. 2 into T of n by 2 plus n. 2 into is T of n by 2 plus c. T of n is equal to 7 into T of n by 2 plus c into n square. T of n is equal to 9 into T of n by 3 plus n power 2.5. There are 4 more, no, 3 more. Shall I write it after we solve all these things? Let's solve all these questions first. You can solve all of them by using substitution method. But slowly, once you start divide and conquer, it will take too much time. Many steps and time is also more. Okay, so first one, T of n. First one, T of n is T of n minus 1 plus 1. See, first you need to understand which theorem you should apply. Please see, this is decrease and conquer, minus T of n minus, which means decrease and conquer. This one decrease and conquer. All are decrease and conquer. But you see here it is n by 2. This is divide and conquer, divide and conquer. All are divide and conquer. And in divide and conquer, if you see the next function f of n, this is n square, which is a polynomial of degree 2. N square, n power 1 by 2, again a polynomial. Okay? N power 1, n power 1. This is some constant into n power 0, because n power 0 is 1. So this is also in the form of n power d, where d is 0, that's all. N power 1. This is again constant, which means it is c into n power 0. Okay, the d is 0. N square, n power 2.5. So all these problems comes under theorem 1 of divide and conquer. Okay, theorem 1 of divide and conquer. I didn't write the problems on theorem 2 yet. We'll solve one by one. Once we are comfortable with this, we'll go for the other ones. Yeah. So up to 6, it is decrease and conquer. From 7 to 16, divide and conquer, theorem 1. You just need to apply the formulas, what I have written. Okay. This is a into t of, which means a is equal to 1 in this case. B is n minus b. B is 1. D is 1 into n power 0. That is the meaning. Some constant, which means constant into n power 0. So d is 0. Now this is a equal to 1 case. A equal to 1 in decrease and conquer. What is the formula? T of n is equal to big O of n power d plus 1. D plus 1. D is 0. 0 plus 1. Okay, shall I write here? 0 plus 1 is 1, which means big O of 1 is the answer. Big O of n. N power 1 means n. Big O of n is the answer. That is first question. Second, please do it on your own. You don't have to look at the board. T of n minus 1 plus n. A is equal to 1 because it is A into T of. B is n minus B, so 1. D is n power 1, so D is 1. A equal to 1 case. A equal to 1 means T of n is equal to big O of n power d plus 1. You remember, if a equal to 1, I have written the formula as big O of n power d plus 1. So big O of n power d is 1, 1 plus 1, 2, which means big O of n square is the answer. Big O of n square. Once you write the reconciliation, straight answer by using Master's theorem. This is what is needed in it. Third question, P of n is 3 times P of n minus 1 plus 1. 1 into n power 0, that is the meaning. If it is a constant, constant into n power 0, polynomial format. A equal to 3, which is greater than 1. So it is A greater than 1 case. Okay, B is 1, D is 0. So if A greater than 1, what is the answer of P of n? Is equal to big O of n power D into A power n by B. Big O of n power D, D is 0. A is 3, 3 power n by 1. Simplify. Big O of n power 0 is 1. So 1 into 3 power n. That's all. So 3 power n is the answer. Fourth question. P of n is equal to P of n minus 1 plus C into n square. See, if you do not remember Master's theorem, then nothing can be done. Okay? You must remember Master's theorem. If you want 2 minutes time, please take your time and then go through the theorem. You must remember the theorem. Then only you can solve all these questions as fast as you can. Okay? A equal to 1, B is n minus B. So B is 1, D is n power D. D is 2. So A equal to 1 case again, P of n is equal to big O of n power D plus 1. Big O of n power D is 2. 2 plus 1 is 3. So big O of n cube. Fifth question. T of n is equal to 2 times T of n minus 1 plus 1. 1 means 1 into n power 0. Constant. Constant into n power 0. Okay. A equal to 2, B equal to 1, D equal to 0. A equal to 2 means greater than 1 case. A is greater than 1. Last one. So T of n is equal to big O of n power D into A power n by B. Big O of n power D is 0, n power 0 into A. A is 2, 2 power n by 1, which means 2 power 1. Big O of n power 0 is 1, so 1 into 2 power n. So answer is big O of 2 power n. It's visible, right? Last one. Big O of 2 power n is the answer for fifth question. Let us solve sixth question. T of n is equal to 2 times T of n minus 1 plus n. A equal to 2, which means A greater than 1 case. B is 1. D is n power 1, which means D is 1. So A greater than 1 is T power n is T of 1 equal to big O of n power D into A power n by B. Big O of n power D is 1 into A power A is 2 power n by 1. So answer is big O of n into 2 power n. Okay, 36th question. Seventh. T of n is equal to 4 into T of n by 2 plus C into n square. Now you see, this is divide. N by 2. Divide and conquer case. And this f of n is in n power d format. It is in the form of polynomial. So n power d. D is highest power. Highest power is 2. Okay. See, if the question is, I'm just changing it just to explain you. Even if it is given like this, some 3 into n square plus 2n minus 2, something like this is given, which means you can happily erase this and write because it's a polynomial, you know that. If f of n is a polynomial, then p of n equal to p of n power d, highest degree, highest power. Okay, we go off, we go omega off and theta off. And we learned it already. So we go off n square. So you can erase this and simply say it is some constant into n square. That is what is given. So divide and conquer. A equal to 4 because A into T of B is equal to n by B. B is 2. D is n power D. D is also fine. Now A is 4. What is B power D? By seeing this, what is B power D? 2 square. 2 square is also 4. So A is equal to B power D case. A equal to B power D case. So what is the formula? A equal to B power D. T of n is equal to, we go on theta. As long as this is T of n is equal to, you can write it as theta, big omega, all of it. If it is equal to, if it is less than or equal to, you must write only big O. If it is greater than or equal to, you must write only omega. Because this is T of n is equal to, you can write theta also. If theta is true, big O is true, big omega is also true. Right? So, what is the answer? T of n is equal to big O of A equal to B power D is n power D into log n. N power D into log n. Big O of n power D. What is D is 2. So, n square into log n. Question? T of n is 8 into T of n by 2 plus n square. Should solve it. What is A, B, D, and the relation between A and B power D. A is 8, B is 2, D is 2. What is B power D? 2 square, only 4. A is 8, B power D is 4. Which means A is greater than B power D case. If A is greater than B power D, what is T of n formula? Theta or big O of n power log A to the base. N power log A to the base. Okay, theta of n power log A. A is 8, B is 2. What is log 8 to the base 2? 8 can be written as, what is log 8 to the base 2? 8 can be written as 2 cube. So that 3 will come forward. 3 into log 2 to the base 2. And log 2 to the base 2 value is 1. So 3 into 1 is 3. Correct? So log 8 to the base 2 is 3. So it becomes theta of n cube. Theta of n cube. Ninth question. T of n is equal to T of n by 2 plus root n, which means n power 1 by 2. This is n power 1 by 2. Right, A equal to 1, B is 2, D is 1 by 2. So what is B power D? 2 power 1 by 2. 1 by 2 means square root of 2. What is square root of 2? 1.414. So you know A value as 1, B value is 1.4. A is less than B power D, correct? A is less than B power D case. So T of n is equal to big O of just n power D. O of n power D. D is 1 by 2, right? So n power 1 by 2 is nothing but O of root n. This is big O of root n. Next question answer is big O of root n. Any doubts till now? So till 9th question we have solved, so I am erasing till 9. Tenth question. T of n is equal to 4 into T of n by 2 plus n. A is equal to 4, B equal to 2, D equal to 1, n power 1. So D is 1. What is B power D? B power D is 2 power 1, 2. So A is 4, B power D is 2. A is greater than B power D case. A is greater than B power D case. So T of n is equal to big O of n power log A to the base B. Okay. So it is big O of n power log 4 to the base 2. What is log 4 to the base 2? Just 2. Because 4 can be written as 2 square, that 2 will come forward. Log 2 to the base 2 will be 1. So 2 into 1 is 2. N power. 11th question. T of n is equal to T of n by 3 plus n. So A equal to 1 because it is A into T of. So A is 1, B is n by B. B is 3, D is n power D. D is 1. What is B power D? B power D is 3 power 1, which is 3. A is less than B power D. A is less than B power D case, so T of n is equal to big O of n power D only. Big O of D is 1, so n power 1, big O of n. That's all. The 12th question. T of n is equal to 2 times T of n by 2 plus C. C means C into n power 0. Because n power 0 is anyway 1. 1 into C is. Then A equal to 2, B equal to n by B. B is also 2. D is n power 0. So D is 0. What is B power D? 2 power 0. 2 power 0. Anything power 0 is 1. So 2 power 0 is 1. A is 2, B power D is 1. So A is greater than B power D case. A greater than B power D case. So T of n is equal to big O of n power log A to the base B. N power log A to the base B. Big O of n power log A is 2. B is also 2. Log 2 to the base 2. Log 2 to the base 2 is 1. So n power 1. Big O of n power 1, which means big O of n. Right? Hope everybody is solving on the book. Okay? you are just trying to take a screenshot of the book. Please solve it. Please solve it on your own. If you just listen, everything looks like you understood everything. Question number 13. T of n is equal to 2 into T of m by 2 plus m. So A is equal to 2, B is n by b, B is also 2, D is n power d, D is 1. So what is b power d? 2 power 1 is 2. A is also 2, b power d is also 2, which means A equal to b power d. So if A is equal to b power d, what is T of n formula? T of n is equal to big O of n power d into log n. So big O of n power d, d is 1, so n power 1 into log n, which means n log n. Big O of n log n. 14th question. T of n is equal to T of n by 2 plus c, which means c into n power 0, which is d is 0. So A equal to 1, B is 2 by B, A is 1 into T. So D is n power 0. So what is B power D now? 2 power 0 is 1. 2 power 0 is 1. So A equal to B power D case. Again A equal to B power D case. If A is equal to B power D, then T of n is equal to big O of n power D into log n. N power d, d is 0. N power 0 becomes 1 now. Because it is n power 0 into log n. Answer will be big O of log n. Because n power 0 is 1. 15. T of n is equal to 7 into T of n by 2 plus c into n square. A is 7, B is 2, D is 2. What is B power D? 2 square is 4. A is greater than B power D case. A greater than B power D case. So T of n is equal to big O of n power log A to the base B, which is n power log 7 to the base 2. What is log 7 to the base 2? Log 8 to the base 2 will be 3. Okay, but log 7 to the base 2 is less than 3. It is approximately n power 2.81. Approximately. You can leave it like this, but if you want the exact answer, it is big O of n power 2.8. Sixteenth question. T of n is equal to 9 into T of n by 3 plus n power 2.5. So A is equal to 9, B is equal to 3, D is equal to 2.5. What is B power D? Which means 3 power 2.5. See, 3 square itself is 9. Power is more than 2, right? It is 2.5, not just 2. Okay, so 3 square itself is 9. So 3 power 2.5 will be more than 9. So b power d is greater than 9, which means a is less than b power d. A is less than b power d case. So t of n is equal to big O of 1 power d. 1 power d. So it is big O of n power d is 2.5. So n power 2.5. That's all. It is 16th question. So it depends on A, B, D values. Based on a relation between A and B power D, we are, we are finalizing the formula and we are just substituting. Let me write other problems. 17. T of n is equal to 2 into T of n by 4 plus 0.5. So n power 0.5. What is 0.5? 0.5 is, which means 1 by 2. 1 by 2 is 0.5. 1 by 2 means n power 1 by 2 means square root of n. Instead of giving square root of n, they just mention n power 0.5. Okay, so A is equal to 2, B is equal to 4, D is equal to 0.5, which means 1 by 2. What is B power D? 4 power 1 by 2, which means square root of 4. Square root of 4 is 2. A is 2, B power D is also 2, which is equal to A equal to B power D case. So T of n is equal to of n power D into log of n power d. D is 1 by 2. So n power 1 by 2 into log n, which can also be written as big O of root n into log n. Root n into log n. Okay. Yeah, next two problems. See, I'm writing 18 and 19. 18 is T of n is equal to T of root n plus 1. 19 is T of n is equal to 2 times T of root n plus log n. You need to solve these two questions now. Okay. Just look at these two questions. solution for 18? This is neither decrease and conquer nor divide and conquer. Correct? It is not n power n minus something. It is not n by something. It is n power 1 by 2. This is a problem. So whenever you see root n or log n inside t of, then you must go with change of variable method. Okay? It is change of variable method. Whenever you see root n or log n in t of, go for change of variable method. I will solve the 18th question. You must solve 19th question. Okay? Question. T of n is equal to T of root n plus 1. I'm saying let n is equal to 2 power m. I'm changing the variable. Till now the equation is in n. I'm changing it to m. That is change of variable. But I am assuming n is equal to 2 power m. Then what is m? That implies m is equal to log n to the base 2, correct? If you want, apply log on both sides. This is log n, this is log of 2 power m. M will be in front of log 2 to the base 2 will be 1. So it is equal to m. M means log n. Fine. Okay, then we substitute here. Let, because n is 2 power m, substitute here. T of 2 power m is equal to T of n power 1 by 2. But what is n? N is 2 power m. So it is 2 power m whole power 1 by 2, which is 2 power m by 2. 2 power m by 2 plus 1 is as it is. Okay, then I am saying let T of 2 power m is equal to S of m. Just changing it because we know what is T of n. So similarly, if S of n, same formula, right? We can apply something. So if this is the case, then what is T of 2 power m by 2? Wherever you have m, it becomes m. Now if it is S of m by 2, here it becomes 2 power m by 2. That's a substitution only. T of 2 power m is S of n by 2 is T of 2 power m by 2. Okay, so I am substituting these two in the above equation. T of 2 power m is S of m is equal to T of 2 power m by 2 is S of m by 2 plus 1 is as it is. Now it has come to an equation which you know. Divide and conquer. Like T of n is equal to T of n by 2 plus constant. It is in that format only, correct? Now you can straight away apply Master's theorem 1. Divide and conquer Master's theorem 1. So A is equal to 1, B is equal to m by b, B is 2, D is 1 into m power 0, m power 0, 0, m power 0. That is a mean. So D is 0. So B power D is B power D, 2 power 0 is 1. A is also 1, B power D is also 1. So A equal to B power D case. If A is equal to B power D, what is the answer for S of m? S of m is equal to theta of m power. See, everything is in m, that's why I'm writing it in m. I changed the variable. Now you should solve everything in m only. M power d into log m. So big of m power d, d is 0, m power 0 into log m. But m power 0 is 1. So 1 into log m. So big of log m. Okay. So S of m answer is big of log m. But I want the answer in terms of m. I need to change it back to m. Correct? So if S of m is equal to this, T of n is equal to, everything keep it in terms of n. Big of log, what is m in terms of n? M means
Ma'am, Navata ma'am, Navata ma'am,
మేడం వినిపిస్తుందండి?
ma'am,
యా
Navata
చెప్పండి.
ma'am.
హలో,
Yes ma'am, but no, board was not ma'am.
మ్యామ్ వినిపిస్తుందండి?
నవత మ్యామ్.
ఎస్ ఎస్.
ఎస్ మ్యామ్ వినిపిస్తుంది మేడం. కానీ బోర్డు
వినిపిస్తుంది.
క్లియర్ గా కనిపించట్లేదు మేడం, చాలా బ్లర్ గా ఉంది.
ఓ
బోర్డ్ వాజ్ నాట్ విజిబుల్ క్లియర్లీ మ్యామ్. మా స్టూడెంట్స్ ఎవరైనా రెస్పాన్స్ ఇవ్వండి. ఎవరికైనా బాగానే క్లియర్ గా కనిపిస్తుందా మీకు?
నో మ్యామ్, బ్లర్ ఉంది.
1 సెకండ్. అడ్జస్ట్ అయితే చెప్పండి అమ్మా ఒకసారి.
మ్యామ్ బానే ఉంది మ్యామ్.
ఓకే ఓకే మ్యామ్.
ఓకే, ఇప్పుడు క్లియర్ గానే ఉందా?
ఎస్ మ్యామ్.
ఓకే ఫైన్. So m means log n. So just substitute log n in place of m. So the final answer for t of n is equal of log n. It is log n. So what we have done is, because it is in the form of n square root of m or log n, we changed it to m. Assuming that n is 2 power m, so that everything comes to our format of normal divide and conquer. That's why I assume like this: t of 2 power m is equal to t of 2 power m by 2, because it is n is 2 power m, 2 power m whole power 1 by 2, 2 power m whole power 1 by 2. That's why it is 2 power m by 2. Okay, plus 1 is as it is. So I'm assuming this to be s of m. So obviously this becomes s of m by 2. So I substituted both the above equation, so that s of m equal to s of m by 2 plus 1. 1 means constant into m power 0, because everything is in m, you should write it as m power 0. So a is 1, b is 2, d is 0, a equal to b power d case. So s of m, we are solving this equation only. So s of m equal to b of m power d into log m, but d is 0, m power 0 becomes 1, 1 into log m. So we got the solution for this equation. For this equation, the solution is log m. But we are interested in this equation, right? So everything you change it back to n, so that t of n becomes equal of log of m means already substituted, right? M means log n. So log of log n is the answer. So you follow the same method and solve the 19th question. Is full board visible? Question. T of n is equal to 2 into t of root n plus log n. Whenever you see root n or log n in t of, it is neither minus nor divide. Okay, then you should go for change of variable method. So let n is equal to 2 power n. That means n is equal to log n to the base 2. This power is equal to log n to the base 2. So substitute back. So t of 2 power m is equal to 2 into t of 2 power m whole power 1 by 2. So it is 2 power m by 2 plus, what is log n? Log n is nothing but m. So substitute it, because we changed everything to m. We should not have n inside again. Okay, log n means m. Substitute m. Let t of 2 power m is equal to s of m. That means t of 2 power m by 2 is s of m by 2. Substitute back. S of m is equal to 2 into s of m by 2 plus m as it is. Now this is divide and conquer. Theorem 1, which is in our known format. So A is equal to 2, B is equal to 2, D is equal to M power 1. D is 1. What is B power D case? 2 power 1 is 2. A equal to B power D. A equal to B power D. So if A equal to B power D, we are solving this equation. So the answer for S of M is equal to equal of M power D into log M. M power D into log M. Okay, we go off. M power D is 1, so M power 1 into log M. So it is M log M. This is the solution for this, but I want it for N in terms of N. P of N is equal to we go off. Substitute back. What is M? M means log N into log of what is M again? Log M. That's all. So T of an answer is log N into log N. That is answer. Log N into log N. You must observe this in the options. Okay? Because the final answer should be in terms of N, not M. We changed it to M for our convenience. So this is change of variable method. Here, everything is based on theorem 1 only. Okay? Now we will see reconciliations, which will go to theorem 2. If you solve that also, which means you are very comfortable in solving reconciliation, any type of reconciliation. You can straight away give the time complexity of the algorithms. Where is that also? 19th question. Now we will solve questions based on theorem 2. Question number 20. Till now we have solved 19 questions. Question number 20. T of n is T of n by 2 plus 2 power n. T of n is 6 into T of n by 3 plus n square into log n. T of n is 2 into T of n by 2 plus log n. T of n is 16 into T of n by 4 plus n factorial. T of n is root 2 into T of n by 2 plus log n. T of n is 4 into T of n by 2 plus n square by log n. You can solve all these questions also. You are very comfortable with all reference relations. That's how you can understand. So if you have any difficulty in understanding these questions, please listen to this recorded video again and again, or you solve the same questions again and again. Okay. Question number 20. T of n is equal to T of n by 2 plus 2 power n. See, this is divide and conquer, that's fine. But is this in polynomial format? Is this n power something? No, it is exponential format. 2 power n. So it's not in polynomial format. So it is f of n is not big O of n power d format. Which means you cannot apply theorem 1. So you must go to theorem 2 only. Okay. If it is theorem 2, first thing, what is f of n? F of n is after this whatever you have. Okay. It is 2 power n. Then what is n power log a to the base b? This is what you need to identify first. What is n power log a to the base b? Which means a is 1, b is 2, f of n is 2 power n. There is no d. Okay? Okay, n power log a to the base b. N power log 1 to the base 2. Log 1 answer is 0. We know that. 0. N power 0 is 1. Okay? Till now it is clear? Okay? So you identified what is f of n. What is n power log a to the base b? Now you should think here. What is the relation between f of n and n power log a to the base b? This is a constant, which means like n power 0. This is n power 0. This is 2 power n, which means it is much greater than n square, n cube, n power 4, n power k. This is much greater than n power k. So for this power, even if you add something, even if you add a small value, for example 0.5 or 1, even if you add 1, you should add a small value on epsilon less than 0. A small value, even if you add a small value to the power, still it is n power 0.5 or 0.0, maximum n power 1. But this is much greater than n square, n cube, n power 4. Correct? Which means f of n is much greater than n power log a to the base b plus epsilon. Even if you add some value to the power, still f of n is greater. Which means f of n is equal to big omega of n power log a to the base b plus epsilon. Which means it is going to case 3, correct? F of n is equal to big omega of n power log a to the base b. Then your first question, how would I know whether it is going to case 1, case 2 or case 3? You must observe f of n and n power log a to the base b. That will definitely give you an idea. This is much greater than n power 0. Even if I add something, still this is much greater than. That is how you need to see. Okay? So f of n is greater than n power log a to the base b, even if you add something to the power. So obviously it is coming to, right? Greater than means big omega. So f of n is equal to big omega of n power log a to the base b plus epsilon, which means it is coming to case 3. In case 3, there is one more condition. As I said, 99% it will satisfy, but if you have any doubt, you can check. A into f of n by b. A into f of n by b. What is a value? 1. F of n is 2 power n. F of n is 2 power n. F of n by 2 is 2 power n by 2. Correct? Wherever you have n, it is n by 2 now. So 2 power n by 2. So a is 1, f of n by b is 2 power n by 2. Isn't this less than or equal to some constant into, which means 1 by 2? It can be any constant. Into f of n, what is f of n? 2 power n. This is n, 2 power n by 2. This is 2 power n. Even if you multiply with a constant, which means 1 by 2. See, this is 2 power n by 2, which means this is equal to 2 power n minus 1. This is n by 2, this is n minus 1. Obviously, this is much less than 2 power n minus 1. So, a into f of n by b is less than or equal to some constant into f of n. Obviously, satisfied. Correct? So, a into f of n by b is less than or equal to some constant into f. No doubt. So, second condition is also satisfied for case 3. So, by case 3 answer. Oh, you understood that it is case 3, but you do not remember this. Then everything is gone. Then T of n is equal to theta of f of n. So theta of f of n is 2 power n. Answer is 2 power n. So for this reconciliation, answer is 2 power n. And it is case 3. So 20th question comes under case 3. Let us see 21. T of n is equal to 6 into T of n by 3 plus n square into log n. Okay. Do we say f of n is in polynomial format? No, n square is okay, but n square into log n, then it is not polynomial. This is n square into log n. Some constant into n square is okay. This is not constant into, that's why it is not polynomial format. So obviously, theorem 2. Theorem 1 we cannot apply. So if it is theorem 2, what is the answer? Yes, A is 6, B is 3. What is f of n? F of n is n square into log n. What is n power log a to the base b? N power log 6 to the base 3. Tell me, what is log 6 to the base 3? If it is log 9 to the base 3, then the answer would have been n square. But this is not 9, this is 6, which means much less than 2. Some 1.5, 1.52, something like that. N power 1.5. If it was log 9 to the base 3, then n square. This is 6, that's why it is less than 1. Okay, now you observe. F of n is n square into log n. N square itself is greater than n power 1.52 and n square into log n. So much greater than n square. So this is n power 1.5, which is like square root of n. This is approximately same as n power n into square root of n power 3 by 2. It is almost similar to n power 3 by 2, but that is more than n square. N square into log. Okay, which means even if you add something to the power, for example, some 0.3, still it is not n square. It is not even n square, but this is more than n square. This f of n value is more than n square. This is not even coming to n square. So f of n is much greater than n power log a to the base b plus epsilon. Even if I add something to the power, some small value to the power, still f of n is much greater. That's all. So it is coming to case 3. Correct? So n square into log n is much greater than n power log a to the base b plus epsilon. Even if I add a small value to the power, see that epsilon is for the power. Okay. Still this is greater, which means it is big omega. So f of n is equal to big omega of n power log a to the base b plus epsilon. So it is coming to case 3. But if it is case 3, one more condition need to be tested. That is a into f of n by b. What is a into f of n by b? A is 6. But what is f of n by b? F of n is n square log n by b, which means n by 3. What is f of n by 3? N by 3. Wherever you have n, you need to substitute n by 3. That's all. N by 3 whole square into log n by 3. This is n square by 9 into log of n by 3. This is the value. So 6 into a is 6. F of n by b is this one. N square by 9 into log of n by 3. Simplify. This is 2 times 3 times 2 by 3 into n square into log of n by 3. Okay, till now I just calculated what is a into f of n by b. Now you should tell me, is this less than or equal to some constant into f of n? F of n is n square into log n. Isn't this less than or equal to some constant into n square log n? Tell me. 2 by 3 is as it is, n square is as it is. This is log of n by 3. This is log n. Obviously, log of n by 3 is less than log n. So, less than or equal to is 2. So, a into f of n by b is less than or equal to constant into f of n. Correct? So, second condition is also true. So, y case 3, t of n is equal to theta of f of n. So, theta of, what is f of n? N square into log n. Square into log n. What is the answer? For this reconciliation, the answer is theta of n square log n. May look complicated, but they are not complicated questions. Please understand the theorem carefully. How you will identify to which case it belongs to. This is what is important, that comes with experience. All these questions, then you will understand. And all these questions are from Foreman book. Solve question number 22. T of n is equal to 2 into T of n by 2 plus log n. A is to B is to. F of n is log n. This is f of n. Then n power log a to the base b, you need to calculate n power log 2 to the base 2. What is log 2 to the base 2? 1. So n power 1. Now you need to decide which case it comes to. This is log n. This is n power 1. You know the relation, right? Last week we have written a big relation. Constant less than log n less than root log n less than log n less than root n less than n. Okay, you remember. So in this log n graph will be something like this, whereas n graph is like this. Between log n and this we have root n also. This is log n graph, this is root n, this is n. If you know that, then you should think this is log n, which is less than, f of n is less than n power log a to the base b. It is less than means you should go to big O case. What is the case? If f of n is equal to big O of n power log a to the base b minus epsilon, even if I do a small subtraction from the power, still log n is less than or equal to, f of n is less than or equal to. Obviously, why? Because if I do a small subtraction, compare log n, because f of n, isn't this less than or equal to n power log a to the base b, this is log a to the base b, minus some epsilon 0.5. I just subtracted 0.5. 1 minus 0.5 is 0.5. N power 0.5 is root n. Isn't log n less than or equal to root n? Last week we have seen the relationships, right? So log n is still less than or equal to n power log a to the base b minus epsilon. So obviously it is coming to case 1. So f of n is equal to big O of, because it is less than or equal to, big O of n power log a to the base b minus epsilon. So by case 1, t of n is equal to theta of, what is the formula? N power log a to the base b. N power log a to the base b, which is n power log 2 to the base 2, so theta of n power 1, which is theta of n power theta of n. So that is question number 22.
Ma'am, your mic is muted, ma'am. Ma'am, your mic is in mute, ma'am. We are unable to listen, ma'am.
Can you see? Sorry, can you listen now?
Yes, ma'am.
Yeah. It has happened just now or what?
Yes, ma'am.
Just now. Okay, fine. Does it happen automatically because nobody is here? Okay, see the difference between these two. What is the difference? This is as it is, but this is n into log n. You observe this. A is to B is to f of n is n into log n, and this one n power log a to the base b. This is n power log 2 to the base 2, which is n power 1. This is n, correct? This is log n extra. F of n is log n, which is extra. And this one, if you see log n whole power k, then you should think in terms of case 2. Okay? So in terms of case 2, this is n power log a to the base b as it is. So f of n is theta of n power log a to the base b into log n whole power k, where k is 1, because it is just log n, is log n whole power 1. When you see this one, log a to the base b is also exactly same. So theta equal to, so theta of n power log a to the base b, which is as is, into log n whole power k. So your f of n is in the format of n power log a to the base b into log n whole power k. It comes to this case. Because your n power log a to the base b is as it is. In the previous case, it was not like that. It was just log n. It is not n log n. Okay, that is the difference. So it is coming to case 2. By case 2. Okay. By case 2, the answer depends on k value. But in this case, what is k value? Here k value is 1. Just log n. Log n means log n whole power 1. So k value is 1. So what are the k values that we have seen? K greater than or equal to 0 is first case, right? So if k is greater than or equal to 0, t of n is equal to theta of n power log a to the base b into log n whole power k plus 1. This is the theorem that we have written. So t of n value is n power log 2 to the base 2 into log n whole power k plus 1. K is 1, so it becomes log n whole square. Theta of n power log 2 to the base 2 is n. N into log n whole square. This is the answer for this question. For this question. You just see, whenever you see log n here, you just observe what is in front of it. Is it exactly same as n power log a to the base b? Then it is going to case 2. If it is not in the format of n power log a to the base b, then definitely it is not case 2. Either it is case 1 or case 3 that you need to observe. If you see log n. Because case 2 comes only when you have something into log n. Log n power something. It could be log n power 1, log n power 2. Such a question we have here also in 21. But why didn't we apply case 2? Why it didn't come to case 2? Because if it is 9 into t of n by 3, then this is n power log 9 to the base 3. Then only it is n square. But this is 6 into, which means it is n power 1.58 something, not n square exactly. Because it is not exact n power log a to the base b into log n whole power 1, it didn't come to case 2. If you want, you can write 21b also. 21b. If the question is t of n is equal to 9 into t of n by 3 plus n square into log n, then the answer will be towards case 2, because this is exactly n power log 9 to the base 3 into log n whole power 1, which means log n whole power k. And the k value is greater than or equal to 0 like this. So the answer will be n power log n to the base 3 into log n whole power k plus 1. So log n whole square, and this is log 9 to the base 3, which is n square into log n whole square. That would have been the answer. If you want me to solve, I'll do that. A is 9, B is 3, f of n is n square into log n. N power log a to the base b is n power log 9 to the base 3, which is n square. This n square is exactly here into log n whole power k. So f of n is equal to theta of n power log a to the base b into log n power 1. This is in this format it is. K is equal to 1, which means k greater than or equal to 0, like this. So if k is greater than or equal to 0, t of n is equal to theta of n power log a to the base b into log n whole power k plus 1. So the answer will be theta of n square into log n whole square. This would have been the answer for 21 if it is 9. Yeah, any more questions? Hope you are understanding which case it is coming to. Case 2, theorem 2. Question number 23. T of n is equal to 16 into t of n by 4 plus n factorial. Plus n factorial. N factorial much greater than a polynomial. It is greater than 2 power n. Greater than exponential. Correct? Okay. That's all. So it is not in polynomial format. So theorem 1 cannot be applied. Theorem A is 16, B is 4. F of n is n factorial. N power log a to the base b is n power log 16 to the base 4, which is n square. Or 16 can be written as 4 square. Okay, that is n square, this is n factorial. Now, which case it comes to? You just observe these two values, n factorial, n square. This is just a polynomial. Even in polynomial, the degree is just 2. It is much less than 2 power n itself. And n factorial is much greater than 2 power n. See, this is n square, n cube. On top of it 2 power n, on top of it n factorial, which means n factorial is much greater than n square. So f of n is greater than n power log a to the base b, which means n square in this case. Even if you add some value, some small value, why small value? Let me add 1 itself. Still it is just n cube. Just n cube. But f of n is n factorial, much greater than n cube. So, greater than. So, coming to big omega. So, f of n is equal to omega of n power log a to the base b plus epsilon. Even if you add a small value, still f of n is much greater. So, coming to case 3. But in case 3, I need to check second condition also. What is that? A into f of n by b. A value is 16. F of n is n factorial. F of n by 4 is n by 4 factorial. That's all. This is 16 into n by 4 factorial. Now you should tell me, isn't this less than some constant into n factorial? F of n, some constant into f of n. This is n factorial. This is n by 4. N by 4 itself is a much smaller number when compared with n. Okay, on top of it, it's factorial. See, you just take 16 factorial, such a big number. But if you take this as 4 factorial, such a small number. So, this whole thing is definitely less than some constant into n factorial, no doubt. So, second condition is also true. So, by case 3, T of n is equal to theta of f of n. So, theta of n factorial is the answer. Theta of n factorial is the answer. So, next question, 24. T of n is equal to root n into T of n by 2 plus log n. Okay. This is f of n, not in n power d format. So, you cannot apply theorem now. So, theorem. This is root 2. Sorry, not root 2. So, a equal to root 2, b is equal to 2, f of n is equal to log n, and n power log a to the base b, which is n power log root 2 to the base 2. Log root 2 to the base 2. N power, this is 2 power 1 by 2. That 1 by 2 will come front. Log 2 to the base 2 is 1. So this is root 2. This n power log a to the base b is just root n. This is log n. Now you should tell me. Compare f of n and n power log a to the base b. Log n is less than root n. We know that. Okay. So log n is less than root n. So f of n is less than or equal to n power log a to the base b. Okay. Even if you do a small subtraction from the power, it is 0.5. 0.5. I am saying minus 0.01. Such a small value I am reducing, which is like almost square root of n only. Still log n is less than or equal to. So log n is less than or equal to n power log a to the base b minus epsilon, which means 0.5 minus 0.01, something like that. Still log n is less than or equal to, this is almost to 10, so less than or equal to h2. So f of n is equal to big O of n power log a to the base b minus epsilon. So it's coming to case 1 by case 1. By case 1, t of n is equal to theta of n power log a to the base b. Theta of n power log root 2 to the base 2, which is theta of n power 1 by 2, which is like root n. So answer is root n. Last question. This is the one. A equal to 4, B equal to 2. F of n is n square by log n. So n square is divided with some value. So definitely it is lesser than n square. That is a name. Okay. Then n power log a to the base b, which is n power log 4 to the base 2, which is n square. That is n square. This is n square by log n. So this is much less than n square because you are dividing. You are dividing log n. As n is increasing, log n will be definitely increasing. So as you go on, your value of this is slowly coming down because you are dividing with a bigger number. So n square is greater than n square by log n. So f of n is less than or equal to n power log a to the base b. Even if you do a small subtraction, I'm saying 0.001, it's like almost n square only, almost n square. But this is, as n is increasing, this is much less than n square. So f of n is less than or equal to n power log a to the base b minus epsilon. Even if you do a small subtraction, this is smaller, which means f of n is equal of n power log a to the base b minus epsilon. You want me to write n square by log n is less than or equal to n square minus 0.001. Definitely this is less than because you are dividing with a bigger number as n is increasing. So by case 1, theta of n is equal to theta of n power log a to the base b. Theta of n power log a to the base b. So this is how we need to solve theorem 2 questions. You just need to observe which case it comes to.
Ma'am,
Yes.
ma'am, this question we can solve it by case 2 also. Ma'am.
Right?
Uh,
This is n
I
square,
log n.
n square into log. Yes. In this case, because it is coming to exactly n power log n power log a to the base b, yes, even you can apply that. Case 2 also you can apply. This is like straight. That's fine.
Okay.
The small value is changed, then the story will change. For example, if it is something like this, then you can apply only one case. You can understand. questions, right? You have solved all different cases possible. So this we have completed asymptotic notations. Now we need to solve equations. Everybody has the Google Drive link, right? Where we are solving equations. All the files are present there. Could you please access that? We'll solve some of the questions today and continue the questions today. Hope everybody has the link. Can one of you paste that link in chat box? Access the file 9, question number 9. File number 9, asymptotic notations. File number 9. Everybody has the file, right? Yeah, question number 1. What is the generating function for the sequence of Fibonacci numbers? How do you generate? What is the generating function? You should write in terms of function so that it generates Fibonacci numbers. See, if I want f of n number in Fibonacci, how do you generate it? The generating function is f of n minus 1 plus f of n minus 2. That's all. This is the generating function. Question number 2. Consider the following two functions. g1 of n is equal to n cube for 0 less than or equal to n less than 10,000. But this is n square for n greater than 10,000. This is g1 function. But what is g2 function? This is just n for 0 less than or equal to n less than or equal to 100. It is n cube for n greater than 100. Now, what is the relation between g1 and g2 functions? You need to observe g1 and g2, but this is n cube function up to 10,000. But after 10,000, it is just n square function. Up to 100, it is n function, but after 100, it is n cube. From a particular natural number onwards, which means it is 10,000. After 10,000, this is n square function. After 10,000, after 100 itself. But if you consider n after 10,000, after 10,000 also it is n cube. So, if you draw a graph, for some time, this is just g2 function. Is just n up to 100. But after 100 it is n cube, which means it is going like this. N cube. Okay, this is n cube. It's not n. This is n square. I'm saying that is n cube. This is after 100. Okay. But this one, for some time it is n cube. It is going like this. But after 10,000, for example, if this is 10,000, from here onwards, this g1 function is coming to n square. So this is coming to n square, but this is growing like n cube. From this natural number onwards, g1 is just n square function, but that is n cube function. From a particular natural number, g1 is less than or equal to g2. Correct? For all n greater than or equal to 10,000. So g1 is less than or equal to from a particular natural number, which means g1 is equal of g2. You can write it as g2 is omega of g1. Both are okay. whichever you can find in the options. Please check the options. Hope you remember the definition last week we have discussed. How we identify big O and big omega. Correct? From a particular natural number onwards, which function is dominating which function. As per that, the relation comes. So G1 is big O of G2. Option A. Option A. Then third question. Third question, which of the following is false? We are looking for a false statement. A is 100 into n log n is equal to big O of n log n by 100. B, root log n is equal to big O of log n. C, x less than y, then n power x is equal to big O of n power y. D, 2 power n not equal to big O of n power k. We are looking for a false statement, please remember that. Which means 3 of them are true, only one of them is false. Let us check the first one. Big O of n log n by 100. In big O notation, is there any importance for by 100? No, so you can remove it. Okay, I remove. We know that n log n is equal to big O of n log n. Yes or no? Reflexive property says f of n is equal to big O of f of n. F of n, big O of f of n. Okay. That is reflexive property. We know that. And general property, when f of n is equal to big O of g of n, even if you multiply with a constant on the left hand side, still the relation is fine. This is what we discussed in general property. Yes, so this is a true statement. But we are looking for a false statement. Okay, then let me see option C. If x is less than y, then n power x is equal to big O of. Big O means less than or equal to. If x is less than y, which means 2 and 4. N square is equal to big O of n power 4. Yes or no? N square is big O of n power 4. Obviously true. If x is less than y, n power x is equal to big O of n power 1. This is also true statement. Coming to this, I gave you a formula when I was explaining. N power k is a polynomial. N power k is less than 2 power n, which means n power k equal to big O of 2 power n. But never ever 2 power n is equal to big O of n power k. Correct? 2 power n is never equal to big O of n power k. And that is what he is saying. 2 power n is not equal to big O of n power k. That's a true statement. He said not equal only. N power k is equal to big O of 2 power n. But 2 power n is never equal to big O of n power k. Now let us see this. Log n. Let me say log n is p. In fact, we know this formula. In that relation, I mentioned these two also. But let me explain again. Let log n is equal to p. Substitute this here. Square root of p is equal to big O of log p. This is what is the relation. Is square root of p less than log p? Log p is less than square root of p, correct? But he said square root of p is less than log p. This is false. So this is a false statement. So the answer is this one. We are looking for a false statement. Is that okay? Third question. Any doubts? N power k is a polynomial. This is exponential. Polynomial is always less than or equal to exponential. So n power k is equal to big O of 2 power n. The reverse is not true. And I said it is not true, so it's a true statement. Yes, fourth question. We have not discussed data structures. Shall we discuss this question later? Fourth question. After data structures. As it is coming to link to this. Let us solve fifth question. Consider the following functions. F of n is equal to 2 into n power root n. G of n is equal to 2 power root n into log n. And h of n is equal to n factorial. Which of the following is true? He mentioned the relationship between those three. Let us observe, then we will compare with the options. Okay. Which is the smallest function? Which is the next smallest? Which is the last one? See, we know a relation between n factorial and n power n. But we don't know the relation between n power root n and n factorial. Either you should give values for n and then verify. That is the only option if you want to know a relation between two functions. Let us observe these two first. See, if this is in front of log n, can I keep it on top of this? Logarithm formula. 2 power log n power root n. So that root n comes front into log n. Okay. And this is base 2. And there is a formula in logarithm that a power log b to the base a is, this base and this base are same, the answer is just b. Answer is b. So in this case, this base, both are same, so the answer is n power root n. So f of n is 2 into n power root n, g of n is just n power root n. Tell me, what is the relation between these two functions? Should I say f of n is big O of g of n, big omega of g of n, or theta of g of n? What is the relation between these two functions? This is 2 into n power root n, this is just n power root n. Don't say that g of n is less than or equal to, no. As I told you, if there are two functions such that one function is constant multiple of the other function. So f of n function is like 2 into g of n function only. Two functions are such that one is constant multiple of the other function. Then big O, big omega, theta, all are true between them. So f of n is equal to theta of g of n. So g of n is equal to theta of f of n, which means between these two, from both ways, big O is true, omega is true. Because they are constant multiples of each other. Now we need to know a relation between g of n and h of n. Either f of n and h of n or g of n and h of n, because these two are same functions. The relation between them is equal to. Only confusion is between these two. Let us check. One is n power root n, the other one is n factorial. We need to observe a relation between them. Let's give some small values for n factorial. Shall we say 9 factorial? 9, n value is 9. 7 factorial is 420. So 420 into 8 into 9. That is n factorial value. What is n power root n? n is 9, but root n is 3. 9 cube. What is 9 cube? You know the value. 9 cube is 1000. 9 cube is much less than 1000. But this is 720, right? 720 into 8 into 5 factorial is 120. 6 factorial is 20 into 6 into 7 into 8 into 9. Okay, whatever is the value. Definitely much bigger than 1000, no doubt. Okay, but this is just in cube less than 1000. I'm just talking about a small value 9. But if you go on for 20, 100, 1 lakh, you see n power square root of n is much smaller than n factorial. But n power n is much greater than n factorial. We know this already relation. N square is n factorial is less than n power n. But n power root n is less than n factorial. Okay, so the relation between g of n and h of n is clear. We know that g of n function is less than h of n function. So g of n is equal to big O of h of n, or h of n is equal to big omega of g of n. Now we understood the relation. What is the relation? F of n is equal to g of n, which is less than h of n. Now we understood the relation. So, which option is correct? Observe the values. H of n is less than f of n. Is h of n less than f of n? No. Option A is wrong. Option B. H of n is less than g of n. H of n is less than g of n is also wrong. C. G of n is not equal to big O of f of n. G of n is not equal to big O of f of n. No. Between these two functions, big O, big omega, theta, all are true from both the sides. And he's saying it is not. So that is also false. D. F of n is equal to big O of g of n. F of n is equal to big O of g of n. If theta is true, obviously big O is also true. So the answer is D. Answer is D. If you do not know a relation between two functions, the only thing that you can do is give the values for n. But as n tends to infinity, as n is increasing, you should observe. Don't observe the values when n is very small. You see, in this case, I cannot go to find n factorial. It's pretty clear even for the small values. That's why I have calculated for small values. Okay, this is fifth question. Sixth one. Again, two functions are given. F of n is n square into log n. G of n is n into log n whole power n. Two functions. Okay, what is the relation between them? Okay, we don't know what is the relation between them because they are not the functions that we know, the relation that we know. Okay, if so, give the values for n and then verify, but observe the values as n tends to infinity, not when n is small. Let me see n square into log n.
Ma'am, your mic is muted, ma'am.
Ma'am, your mic is muted, ma'am, again.
What's happening here? Hello? It's
Yes,
clear,
ma'am.
right? How come this is happening today? Okay. Yeah, as I said, this is n square and this is n. I have removed one n from here and one n from here also. N square has become n. I remove one n from here. Similarly, one log n I will remove from here. So that one log n I will remove from here also so that it becomes log n power 9. Just simplified for my calculation. You can keep it as it is and give the values, that's okay. So, f of n function is n, g of n function is log n power 9. I don't know which is smaller function, which is greater function, so I will give the values for n and then verify. N is nothing but f of n, so give the values for n and then verify. Yeah. Shall I give n value as 10 power 10? N value is 10 power 10. Now what will be g of n? Log of 10 power 10 whole power 9. This 10 will come forward. 10 into log 10 to the base 10. Log 10 to the base 10 is, okay, 1. So this is 10 power 9. This 10 has come forward, whole power 9. This is 10 power 10, this is 10 power 9. Looks like almost same, but if you are still not okay, let's go for one more bigger value. 10 power 100. N value is 10 power 100. G of n is 10 log of 10 power 100 whole power 9. This 100 will come forward, 10 log 10 to the base 10 is 1. So 100 power 9, which means 10 square power 9. 10 power 9 twos are 18. This is 10 power 100, this is 10 power 18 only. See, this is 10 power 100. That is 10 power 18 only. So this is much bigger. So f of n function is much bigger than g of n function. F of n is greater than or equal to some constant into g of n. So f of n is equal to omega of g of n. So f of n is not equal to, or the reverse way, g of n is equal to big O of f. Whichever is available in the options. Let's see the options. So you should study the functions as n tends to infinity as the functions are not very clear and they will not give the exact answer when n is small. Our intention is to study the function as n tends to infinity. We have seen the reason, right? Last week. So study the functions as n tends to infinity and then you give the asymptotic notation. So sixth question. F of n is equal to big O of g of n from option B. G of n is equal to big O of f of n and f of n is not equal to big O of g of n. Option B is correct. C is wrong. D, f of n is big O of g of n is wrong. C and D are also wrong. Answer is B. Okay, shall we stop for the day? We'll continue these questions tomorrow. We'll complete all these questions and then we will start divide and conquer. Okay, we just start. This is the introduction. Okay. Solving these questions will take time, but if you can work out these questions today at home, we can go a little fast. Otherwise, okay, we'll go slowly and then we can just start divide and conquer tomorrow. Okay. Any doubts? Any doubts? No questions?